Okay, so welcome everybody. Today we will wrap up wireless transmission chapter 2. In this chapter we already covered the major part in the Q&A session. So what is left is basically the cell structure, the idea of splitting, of segmenting space into cells. This is why in some countries those networks are also called cellular networks. So that's basically space division, multiplexing. We have the base stations, we have certain coverage, we have certain cell sizes, and I will come back to cell sizes when I discuss different technologies. So in cities, sometimes we have only a few hundred meters. On countryside, it could be up to 35 kilometers with a standard GSM. This has nothing to do with weak signals, but as we will see, with the latency. So the signal needs some time to travel from the base station to the mobile station, and there are certain limits because we use time division multiplexing in GSM. I will come back to this and how we can actually double this range up to 70 kilometers. What is quite important that you know that for higher frequencies we have smaller and smaller cells. The problem for higher frequencies is, as you already know, they have really hard times to penetrate walls, for example, or to travel through trees, to people, to whatever there is. For lower frequencies, they can way easier penetrate walls. So in the basement, it is no problem to receive, for example, signals using 400 megahertz, but it's a problem for higher frequencies. So this is why, for example, police, ambulance, firefighters, they go for the lower frequencies. And on our campus network using Wi-Fi, well, we need more than 1,800 hotspots for not even full coverage. So I know that many years ago, some people had the idea, why can't we have full coverage using wireless LAN instead of GSM or whatever? Not a good idea, so due to the frequencies. Okay, so that was the idea of the cell structure. And we also had some questions for this. So think back, what are the main reasons? Why do we do all these problems with thousands? So we have 60, 70,000 base stations for our mobile phone network. Why do we do this? Couldn't we have just one big antenna? Would be an interesting idea to have somewhere Germany and somewhere here a huge antenna. Why don't we do this? Okay, robustness. Very good point is robustness. The problem is if you have a failure here in this central base station, that's it. That's it for the mobile phone network. So if we have in a certain region many of these base stations, they usually have some kind of overlapping coverage like this. And then sometimes we have a so-called umbrella cell. And the umbrella cell then covers the whole region. And if everything works well, we have these many little base stations with their own smaller cells. So that in case of a failure of a single, let's say, base station here, you still have coverage for the users here. Because then the user will automatically fall back into this so-called umbrella cell. The problem there is that you have only a limit capacity per cell. So the umbrella cell, well, maybe has the large coverage, but cannot actually provide appropriate service for the same number of users compared to the many smaller cells. So this is why we have. Yes, and then we have another good answer. The phones would need much more power if they had to send to this central antenna in the middle of Germany, for example. Because, you know, if you have the antenna, then you have this exponential decrease of the signal power. So also the other way around, if you want to send to a base station a bit further away, you need a lot more transmission power. This, by the way, is the reason why having a base station closer to your mobile phone lowers the radiation of your mobile phone. So sometimes you hear these strange arguments, oh, I don't want to have that many base stations. That's absolutely wrong. The more base stations you have, the lower the signal power has to be, so the lower the radiation is. So if you're afraid of radiation, you should have a base station every meter, something like this, because then you have very, very, very low radiation. It's way too expensive, but this idea of having fewer base stations is really stupid, because then you need way more output power. Yeah, that's a problem. Okay, and then we also looked into the comparison of TDM-FDM systems. We will learn that the classical second generation system GSM is such a TDM-FDM system, and we will learn that UMTS is a CDM system. And if you think of the number of simultaneous users, what limits this number? TDM or FDM compared to CDM? Or what happens if you have more and more users in a cell using TDM-FDM or in a cell using CDM technology without any additional whatever regulations? So one answer is, okay, TDM-FDM, if all time slots, all frequencies are occupied, exactly, you cannot accept more users. So you have a hard capacity limit. Exactly, and CDM has a soft capacity. Right, so without any additional limits, I mean, you can always say maximum 50 users per cell, something like this, but without this additional hard limits, you have a soft limit in CDM. So it's squeezing like more and more tissues into a box. If you have n tissues in a box, you can always squeeze another tissue into the box. But, and the but here is, you have way more noise. And this noise lets the cells shrink because you have a maximum output power, you have this power control, so you will transmit with more and more and more power, but there's an upper limit. So, and this lets the cell virtually shrink. That's a problem. And you're right, so the number of time slots, the number of channels, this is the hard limit. And at the same time, as long as you haven't reached this limit, you can always add yet another user in a TDM-FDM scheme, and this will not really influence the other users. In CDM systems, you will always influence the other users because you increase the noise in the cell. So this is the big difference, and this makes cell planning really, really difficult, because these briefing cells, think of whatever a city, and you have this nice layout, and you think, okay, these are all my nice cells, and then suddenly you have a higher load in one of the cells. Then this cell starts shrinking, and then suddenly you have this cell, this is way smaller now, and users now may fall into these gaps. So you don't have full coverage. So, but you cannot assume the worst case, because this is way too expensive. You cannot have many picocells just in case that there are many users. So you have to find out what is the typical use, but at noon maybe in the shopping areas, at midnight rather in the bar areas. So this makes it a little bit more difficult. On the other hand, we learned that for TDM-FDM schemes, we have to borrow frequencies, we borrow whatever time slots, so there are also some problems there. But cellular systems, that's usually the way to go, and that's one of the problems if you use the CDMA technology, or CDM. We'll come to CDMA in the next chapter. So what happens in UMTS? That is one of the questions if there are too many users. So the point is, usually you install a network or you plan a network in the way that you can serve a certain number of customers. So what happens if you have more and more customers? The system will block additional customers. So you don't want to have this effect of the breathing cells, or you will have this effect, but it should be not too extreme. So you will limit the number of users. This means, for example, New Year's Eve, Brandenburg Gate, you cannot access the network. Something similar happens with GSM networks. There's an upper limit, also for LTE. So the network will not allow network access. One of the problems we will discuss when we come to the mobile phone networks is that there is a certain moment where your mobile phone tries to access the network, completely uncoordinated. And this is the moment where you might have collisions. We will discuss this. So there might be collisions between your mobile phone and other mobile phones. But as soon as the network allows you to access the network, there are certain guarantees. So if you have, too many users, so if the network is too crowded, usually it should not happen because you do not allow new users to go into the network. But it might be the case that, for example, a part of the network breaks down. So you lose some cells and suddenly you only have the umbrella cell, like shown here on the right hand side. This limits the number of users. So what do? GSM introduced something that is called access class barring. I will also come back to this when we discuss GSM, but for now it might be interesting for you to know that all your mobile phones, they are actually assigned to a certain access class. And this typically depends on the last digit of your mobile phone number. So, and the last digit can be something between 0 and 9. And if you want to take away some of the load of the network, you can randomly block certain access classes. That means mobile phones with certain last digits. So if you block one digit, for example, number 4, then you lower the load statistically by 10% because you have an equal distribution of the mobile stations to those last digit. If you block 2 digits, you lower the load by 20%. And if you block all 10 digits, you actually block all normal users from the mobile phone network. What does it mean, normal users? You have access classes 10, 11 to 15. And as we will see, 15 is an access class for the network operator. And 11, for example, is for energy provider. Then we have police, etc. And then we have a special access class, number 10. And this access class is used for emergency calls. So emergency calls, they can preempt other calls. So in case you have a crowded, overloaded network, it should be still feasible to dial 112. And this will kick out another user of the network. So that is one way of handling this. And this scheme standardized in the standard 02.11, whatever. We'll come back to the standards when we discuss GSM. But this mechanism is the basic mechanism used in GSM, UMTS, etc. to offload the network if we have too many users. Okay, so more questions to the wireless access.